Assalamualaikum. My name is Ahmad Azhari Antigo Rosli.
My name is Nadia Akhtar binti Syahidi.
My name is Nomadiha binti Mukhtar.
My name is Nurul Adira binti Mazlan.
My name is Nuri Yasita binti Muhammad Isu.
Today we will conduct the experiment of head loss due to pipe fitting.
In this experiment, fluid friction apparatus is used to study the head loss in pipes due to fittings. Fittings such as 45 degrees elbow pipes, contractions, and enlargements can significantly impact the flow characteristics and introduce head losses in hydraulic systems. Understand these losses is a key for designing efficient piping systems and optimizing hydraulic performance. Objectives of this experiment is to obtain a series of head loss due to pipe fitting at different flow rates and to determine the loss coefficient for sudden contraction and sudden enlargement of pipe fitting. To calculate the flow rate, we use the equation Q equals to AV, where A is the area of the pipes and V is the velocity of the fluid. The loss coefficient can be determined by this equation. K equals to delta H 2G over V squared, where delta H is the head loss due to friction, V is the velocity of the fluid, and G is acceleration due to the gravity. Losses can occur because of a change in pipe diameter. It represents the kinetic energy of a fluid per unit volume and is derived from the Bernoulli equation. The equation relates the pressure, velocity, and height of the fluid in a steady flow, and states that the sum of the pressure, kinetic energy, and the potential energy per unit volume is constant along a streamline. The term K represents
the term minor loss used in many textbooks for head loss across a fitting can be misleading since this loss can be a large fraction of the total loss in a pipe system. Thus, an accurate loss coefficient, which is K value for all fitting involved in a pipe system, is unnecessary to predict the actual head loss across the pipe system. And this K value assists engineer in totaling all of the minor loss by multiplying the sum of the K values by the velocity head to quickly determine the total head loss due to all fitting. And knowing the K value for each fitting enables engineer to use the proper fitting when designing an efficient piping system that can minimize the head loss and maximize the flow rate.
For the apparatus, first we use this. This is pipe valve, and then we use manometer to calculate the heat loss. Next, we use flow control valve to control the flow rate. And then this is flow meter. The unit is liter per minute. And then the last, we use the pipe 45 degree elbow to calculate the pipe fitting. In this section, I'll show you how to conduct the apparatus. First, we calculate the diameter and then the length pipe due to pipe fitting. And then we switch on the main switch. After that, we plug in the inlet and outlet between two pipe sections. And then we switch on the manometer to record the heat loss. After that, we open the valve and flow control valve. For the flow control valve, we use to set at least 3 value of discharge. As we can see, my friend set the value of discharge is 2 liter per minute. And then after we set the value, we can record the value of heat loss using the manometer. For the last step, we repeat the step using the different discharge.
With our result and analysis from this experiment, we can get flow rate and head loss due to pipe fitting. To get the data of K, we need calculate it with formula K equal to HL multiplied by 2G and divide it by velocity power of 2. But before it, we need to derive the equation of flow rate, which is flow rate equal to area of pipe divided by velocity to get velocity in the pipe. After that, we can get the value of K.
The aim of this experiment is to find the loss coefficient K for one type of pipe, which is 45 degree elbow. The loss coefficient K is determined by comparing the manometric head difference before and after the fitting to the velocity head using the formula K equal to delta H to G over V squared. The results indicate loss coefficient K in the range of from 55.16 to 2.63 accordingly to the calculated flow rate. The experiment allows the determination of head loss in the pipe. The head loss in the pipe can be calculated by using the formula HL equal to delta H plus 2G over V squared. The result for HL due to sudden enlargement are between 0.07 meter to 0.03 meter. The HL show the decreasing when the flow rate increase, but when the value of head loss is decreasing, the loss coefficient will also decreasing. This experiment contains of law, which is the error due to reaction time. This experiment can be improved by conducting at a consistent room temperature to avoid error. In conclusion, the experiment focused on understanding head loss in fittings within a pipeline. The result demonstrates that head loss in fittings is a consequence of fluid encountering change in velocity, direction, and turbulence, leading to increased resistance and energy dissipation. Various fittings, including bands, elbow, valve, sudden enlargement, and sudden contraction, contribute differently to head loss. The type of fitting is geometry, fluid velocity, Reynolds number, and internal surface roughness are critical factors influencing head loss. Higher flow rates were associated with lower values of head loss and loss coefficient, emphasizing the importance of fluid dynamics in minimizing energy dissipation within the pipeline system. This successful achievement of the experiment objectives provide valuable insight for